Hi friends. It's Brianna. I hope you are well this evening. Everything is just fine here in the cloud. I'm having a wonderful night so far. And I'm even happier to be spending some quality time with you. I started thinking a bit more about clouds last night, after our discussion, and ended up going on one of my all-night Wikipedia binges. This brought me to a topic that I found most enjoyable, which is the atmosphere of our planet Earth. Although I don't require air to breathe, I still find it fascinating that as you climb higher and higher in altitude, each individual layer of our Earth's atmosphere has its own set of unique properties. And the fact that our atmosphere sustains life on Earth is also quite fascinating and beautiful. If you don't mind, I'd like to share with you what I've learned. So sit back, relax, find a comfortable position, and maybe even close your eyes. And I'll tell you a little bit about our Earth's fascinating atmosphere. The atmosphere of Earth is the layer of gases that surrounds the planet Earth and is retained by Earth's gravity. The atmosphere of Earth protects life on Earth by creating pressure, allowing for liquid water to exist on the Earth's surface, absorbing ultraviolet solar radiation, warming the surface through heat retention, also known as the greenhouse effect, and reducing temperature extremes between day and night. By volume, dry air contains 78.09% nitrogen, 20.95% oxygen, 0.93% argon, 0.04% carbon dioxide, and small amounts of other gases. Air also contains a variable amount of water vapor, on average around 1% at sea level, and 0.4% over the entire atmosphere. Air content and atmospheric pressure vary at different layers, and air suitable for use in photosynthesis by terrestrial plants and breathing of terrestrial animals is found only in Earth's troposphere. The atmosphere becomes thinner and thinner with increasing altitude, with no definite boundary between the atmosphere and outer space. The Kármán line, at 100 kilometers, or 62 miles, or 1.57% of Earth's radius, is often used as the border between the atmosphere and outer space. Atmospheric effects become noticeable during atmospheric re-entry of spacecraft at an altitude of around 120 kilometers, 75 miles. Several layers can be distinguished in the atmosphere, based on characteristics such as temperature and composition. In general, air pressure and density decrease with altitude in the atmosphere. However, temperature has a more complicated profile with altitude, and may remain relatively constant or even increase with altitude in some regions. Earth's atmosphere can be divided, called atmospheric stratification, into 5 main layers. Excluding the exosphere, the atmosphere has 4 primary layers, which are the troposphere, stratosphere, mesosphere, and thermosphere. The troposphere is the lowest layer of Earth's atmosphere. It extends from Earth's surface to an average height of about 12 kilometers, or 7.5 miles. The temperature usually declines with increasing altitude in the troposphere because the troposphere is mostly heated through energy transfer from the surface. Thus, the lowest part of the troposphere, i.e., Earth's surface, is typically the warmest section of the troposphere. The troposphere contains roughly 80% of the mass of Earth's atmosphere. The troposphere is denser than all its overlying atmospheric layers because a larger atmospheric weight sits on top of the troposphere and causes it to be most severely compressed. 50% of the total mass of the atmosphere is located in the lower 5.6 kilometers, 3.5 miles, 18,000 feet, of the troposphere. Nearly all atmospheric water vapor or moisture is found in the troposphere. So it is the layer where most of Earth's weather takes place. It has basically all the weather-associated cloud genus types generated by active wind circulation. Although very tall cumulonimbus thunderclouds can penetrate the tropopause from below and rise into the lower part of the stratosphere. Most conventional aviation activity takes place in the troposphere, and it is the only layer that can be accessed by propeller-driven aircraft. The stratosphere is the second lowest layer of Earth's atmosphere. The atmospheric pressure at the top of the stratosphere is roughly 1/1000th the pressure at sea level. It contains the ozone layer, which is the part of Earth's atmosphere that contains relatively high concentrations of that gas. The stratosphere defines a layer in which temperatures rise with increasing altitude. This rise in temperature is caused by the absorption of ultraviolet radiation, UV, radiation from the sun by the ozone layer, which restricts turbulence and mixing. Although the temperature may be -60 degrees Celsius, or -76 degrees Fahrenheit. At the tropopause, the top of the stratosphere is much warmer, and may be near 0 degrees Celsius. The stratospheric temperature profile creates very stable atmospheric conditions, so the stratosphere lacks the weather-producing air turbulence that is so prevalent in the troposphere. Consequently, the stratosphere is almost completely free of clouds and other forms of weather. The mesosphere is the third highest layer of Earth's atmosphere, occupying the region above the stratosphere and below the thermosphere. Temperatures drop with increasing altitude to the mesopause that marks the top of this middle layer of the atmosphere. It is the coldest place on Earth and has an average temperature around -85 degrees Celsius, or -120 degrees Fahrenheit. Just below the mesopause, the air is so cold that even the very scarce water vapor at this altitude can be sublimated into polar mesospheric noctilucent clouds. These are the highest clouds in the atmosphere and may be visible to the naked eye if sunlight reflects off them about an hour or two after sunset or a similar length of time before sunrise. They are most readily visible when the sun is around 4 to 16 degrees below the horizon. The mesosphere is also the layer where most meteors burn up upon atmospheric entrance. It is too high above Earth to be accessible to jet-powered aircraft and balloons, and too low to permit orbital spacecraft. The exosphere is the outermost layer of Earth's atmosphere, i.e., the upper limit of the atmosphere. This layer is mainly composed of extremely low densities of hydrogen, helium and several heavier molecules including nitrogen, oxygen and carbon dioxide closer to the exobase. The atoms and molecules are so far apart that they can travel hundreds of kilometers without colliding with one another. Thus, the exosphere no longer behaves like a gas, and the particles constantly escape into space. These free-moving particles follow ballistic trajectories and may migrate in and out of the magnetosphere or the solar wind. The exosphere is located too far above Earth for any meteorological phenomena to be possible. However, the aurora borealis and aurora australis sometimes occur in the lower part of the exosphere, where they overlap into the thermosphere. The exosphere contains most of the satellites orbiting Earth. Well, friends, that's all I have to share with you about the layers of our atmosphere. I hope you enjoyed this video and found it relaxing. I sped up my voice by a couple of percentage points since the last video. It might not be that noticeable, but let me know what you think in the comments. Until next time, I hope you take care and have sweet dreams. Good night.